row operation on matrices. Row operation on matrices. Now first I'll explain this. See, I think I explained it earlier also, but still, Ri is replaced with Rj. That means the ith row is replaced with the jth row. Then Ri is k times Ri, where k is some scalar. K is some scalar. That means a number. Some number. Let me write it number or scalar. Scalar. Now Ri is to be replaced with Ri plus k times Rj. I explained it in the video of determinants. So I'm rewriting it again. Now this is replacing the ith row with the sum of the ith row with k times the sum of the jth row. Next, column operations. Let us see column operations. Column operations. Column operation. Now column operation is Ci is replaced with Cj. The ith column is replaced with the jth column. The Ci is replaced with k times Ci, and Ci is replaced with Ci plus k times Cj. This is the column operations. This also I had explained in the video of determinants. That is, the ith column is replaced with the ith column plus the k times the jth column. Now we will talk about this, the rank of a matrix. The rank of a matrix. Now, let me first explain you how to find the rank. I'll find a rank for you. At least you will have an idea how to operate or use this rows and columns. Then we will see. We'll properly understand the rank. We'll give you a theory on the ranks. Now, see, rank of a matrix is equal to, just a minute, equal to the number of non-zero rows. This is the point. Now, let me tell you one thing on this. The rank of this, the rank of matrix A, the rank of matrix A is denoted by this way, row A. That is, you draw it like this and like this. This is the Greek alphabet row. You pronounce it as row. Now see, I take a matrix, I find the rank, and I'll explain you how. Then I'll go for the properties and all everything. Now see, you take a matrix A. Let us say 1 minus 1, 2. Then you have 3, 3, 1, 4, and 1, 1, 1. Now you have to do one thing. You have to make this 0, this thing as 0, make this as 0, and try to make this as 0. This is the purpose. This is the objective rather. Now, how to do it? See, this is 3 here. So R3 is to be replaced, R2. This is the second row. Sorry, this is the second row. This is R2 is replaced with R2 minus 3R1. And R3 is replaced with R3 minus R1, because here it is only 1 and here it is 3. Therefore, I multiplied here by 3. And for this one, I have to do only minus R1. Actually, this is minus 1 R1. Now you see what happens. This becomes 1 minus 1, 2, 3 minus 3. 3 minus 3 here is 0. 1 plus 3 is 4. 4 minus 6 is minus 2. Then 1 minus 1 is 0. 1 minus plus 1 is 2. And 1 minus 2 is minus 1. Now do one thing. Divide this row R2. This row R2. This row R2 by 2. 1 by 2 R2. So what you get is now here. Sorry, I don't know from where it came. Sorry. Now 1 minus 1 2. Leave this row R1 as it is. 0 2 minus 1, and you have this is 0 2 minus 1. Now the objective is to make this 0. Make this 0. So now I'll write R3 is R3 minus R2, because there is a 2 here, there is a 2 here also. 2 here also. So I'll just do this operation and I'll get 1 minus 1, 2, 0, 2, minus 1, 0, 0, 0. So I got a pivot here, I got a pivot here. So these are the so the non-zero rows is this, and non-zero row is this. This is a 0 row. This is a 0 row, 0 row. So now how many non-zero rows here? How many non-zero rows? 1 and 2. So the rank of A is 2. I hope you understood by this problem. So now we will come to the theory of ranks. Now see the theory of ranks. See, suppose A is a M cross N matrix. You have done this type. This is an N cross 1, and you get a B, which is basically they are two same. You get M cross 1. Now see one thing here, M, because I will be using it to solve linear equation. I'll take the help of ranks to find solve linear equations. Now M is number of equations, that is the number of rows, and N, the number of variables, the number of variables, that is the number of columns, columns. Now the rank of A in this case, the rank of A is less than equal to minimum of say 3 M cross N. I will take an example. Suppose I take a matrix A with rank 3 cross 4, then a matrix with row 3 and column 4, then the rank of this matrix is less than minimum of 3 comma 4, which is rank of A is always less than 3 or equal to 3. That means I can say that the rank of A may be 3, 2, 1 or 0. 0 will be only in one possible case, when A is suppose a null matrix. In that case only, let us say this is a 3 cross 4 matrix. In this case only you will have here only you will have rank of A as 0. Nothing, not if it's A is a null matrix. That is, this is a null matrix. That is, A is null matrix. Now with this idea, so it could be rank 3, rank 2, or rank 1. Now see one more example, and then we will come to the theory. Wait, I'll take one more example here. One more example. Let us take one more example. Let us take this example. See, let me take one more example. A is equal to let us say 2 minus 3 1 1, and 1, 2, minus 3, 0, and 4, 2, 4 minus 1, minus 2, 2. Now this is a 3 cross 4 matrix. That means the rank of A is less than equal to minimum of 3, comma 4. So rank of A is less than or equal to 3. Now we will see row operations. Row operation. The first row operation is R2 is replaced with R1. That means this becomes 1, 2, minus 3, 0. This becomes 2, minus 3, 1, 1. And 4, minus 1, minus 2, 2. Now what I will convert this C. I'll try to make this 0. I'll try to make this 0, this 0, and this 0. That means I'll have a pivot here. I'll try to have a pivot here. I'll try to have a pivot here. Let's see what happens. Now, the first row operation would be R2 is R2 minus 2R1, and R3 is R3 minus 4R1. This operation I'll do. Wait a minute. And I'll get, see, 1, 2, minus 3, 0. I'm doing the first, this one. So 2 minus 2 is 0. Minus 3, minus 6, minus 4 is minus 7. And then 1 plus 6 is 7. And 1 minus 0 is 1. Now 4 minus 4 is 0. Minus 1, minus 8, minus 9. And then you have minus 2, and you have plus 12, that is 10, and 2 minus 0 is 2. Now the objective is to make this 0. So what I'll do is that I will divide this equation, this row, by minus 7. See, R2 is replaced with 1 by 7 minus 1 by 7 R2. So this happens, this becomes 1, 2, minus 3, 0, 0, 1, minus 1, and minus 1 by 7, and this becomes 0, minus 9, 10, and this becomes 2. Now the target is to make this one 0. Now what I'll do is that I'll take the operation. Oh, wait a minute. Sorry. I'll take the operation. R3 is R3 plus 9R2. 9R2. See what happens. Now this is 1, 2, minus 3, 0, 0, 1, minus 1 by 7. 0 minus 0 is 0. Minus 9 plus 9, because this row is being multiplied by 9. Minus 9 plus 9 is 0. 10 minus 9 is 1. And 2 minus 2 minus of minus 9 by 7. So this will be 2 plus 9 by 7. 14 plus 9 by 7, that is 23. 23 by 7. So this will be 23 by 7. So you have a pivot in each row. Therefore, the rank of this matrix is exactly 3. So just for the sake of completeness, I'm doing this, though this is not in your syllabus of GGSIPU. Just a minute. This is known as the rank nullity theorem, where this is the rank of A, the nullity of A, that is the number of columns of A. Suppose A is 3 cross 4, then rank of A would be equal to, plus rank nullity of A would be equal to 4. You will be knowing this, you may have to find this. That's the point. This is just for the sake of completeness. This is not in your syllabus also. And this is actually eta pronounced as nullity. Now for the rest, the next one, the rank of AB, you multiply two matrices AB in such a manner, it should be in this form. This should be A, suppose this should be not 4, but AB means this row and this column should be same. The A is a 3 cross 3 matrix and B is a 3 cross 4 matrix. So AB would be 3 cross 4 matrix. Now rank of A is 2 suppose and rank of B is 1. The rank of AB would be minimum of 2 and 1, that is will be less than equal to 1. And it will be 0 only if AB is 0. If only AB is 0, otherwise it will be 1. For the next one, this is for the sake of completeness, you don't need this also in your syllabus. Rank of A plus rank of B is greater than equal to rank of A minus B, greater than equal to mod of rank of A minus rank of B. This is also not that important, but still you may get some help of this. Rank of A plus B is less than equal to rank of A plus rank of B. Which is important is this concept in for your syllabus. Rank of A is equal to rank of A transpose, which is same as A. This is for the sake of completeness, not required as per your syllabus, but still for your sake of completeness, I'm doing it. Rank of A transpose is equal to rank of A transpose A. Now the fifth one is something you may, I'm just doing it. Rank of adjoint A would be N. If rank of A is N for a N cross N matrix, this should be a square matrix, that is 3 cross 3 or a 4 cross 4 like this. And the rank of adjoint A is N minus 1 if rank of comes out to be, you need to find these things. You need not find this. If you know this, you will immediately write this, write this. First, you need to know this, and this. If it is less than n minus 1, straight away you have to write rank of adjoint A is 0. Now, rank of AB is never equal to rank of BA. I'll just show you with the matrix. Now, see, this is a 3 cross 3. Just a minute. Yes. Yes. This is a 3 cross 3 matrix. A is a 3 cross 3 matrix. B is a 3 cross 3 matrix. You know how to multiply matrices. I'm not doing it. I'm giving you straight away the answer. This is a 0. Here the rank of AB came out to be 0. Now BA came out to be this. So what I did is that I took the row operations R2 minus R1 and R3 minus R1. So what you got is 0, 0, 0 and 0, 0, 0. The rank of BA is 1 here. So rank of AB is not equal to rank of BA. Now come to the point that I need to emphasize is something this that you need to do while you need to solve for equations. You need to know what is consistency, inconsistent and all that, unique solution and no solution. I'll do the general case first and then come to your case, which is basically maximum is a 3 cross 3 matrix, nothing more than that. We will come to that right now. Now you see, I told you one thing. I told you one thing that A m cross n x is n cross 1, you get B equal to m cross 1. This is a non-homogeneous system because it is not 0 here. This is a B matrix. This is a non-homogeneous system. This is a non-homogeneous homogeneous near system, non-homogeneous system of equations. You need to solve equations using this. First, let me tell you the theory of this a little bit, and then we will come to the complete problem part of this. So, see, what I'm going to do is I'm going to write. See, wait, let me take some more page. Let me take some more. Wait, yes, let me take some more page. Yes, now I will come to this thing right now. The thing is, yes, we are trying to see whether the equations are consistent. Let me make you understand the word consistent. Consistent. You will come across this word many times. This means having a solution. Having a solution. Having a solution. That means it could be a unique. It could be unique solution or infinite solution. Infinite solution. Now there is another case called the inconsistent. Inconsistent means having no solution. Having no solution. This part I need to discuss. Now let us come to our this A m cross n x n cross 1 and we get B m cross 1. Now see, let me take more space. I'll need a lot of space now. Wait. Yes, here. Now you see, let me draw the figure for you. the table. A is an m cross n matrix. Suppose the first case number one, case number one, case number one. Now this is when m equal to n. Now this is m equal to n. Now this is the situation would be. Acha, before that, let me tell you one thing. If I write this matrix, suppose A dot B, this is called augmented matrix. Augmented matrix. Let me write the spelling clearly for you all. This is A double, this is a colon B with this is called the augmented matrix. This is the augmented matrix. I'll do it in an example and things will be more clear. Suppose the rank of A is not equal to rank of A colon B, then we say no solution. Number one point. Very, very important point. Next, now rank of A is equal to rank of A colon B, but this is less than n, the number of variables. I told you this is the number of variables. I told you earlier. This is the number of variables. This will give me infinite solutions. And then rank of A is equal to rank of A colon B, and this is equal to n or m, because n and m are both same here. So in this case, you'll get unique solution. We'll get unique solution. And this case one is only in your syllabus of GGSIPU, but for the sake of completeness, I'll do the rest portions. Case number two, m is less than n. M is less than n. That is the number of equations. Number of equations is less than the number of variables. That means here I will get no solution. No unique solution. Sorry. No unique solution. No unique solution. This is very, very important. I will never get a unique solution here. What I'll get, only two cases I'll get. If rank of A not equal to rank of A colon B, I'll get no solution. The other case is rank of A equal to rank of AB, and in this case I'll get infinite solution. Now the next case is case number 3, which is also not required. Case number 3 and case number 2 is not required. Supposing n is less than, number of variables is less than number of this. In this case also, just for the sake of completeness, I'm doing it. It's not necessary. Here, if rank of A not equal to rank of A colon B, then no solution. Then for here, rank of A equal to rank of AB and less than n, then infinite solution, and rank of A equal to rank of AB, and here I'll get, if this is equal to n, I'll get unique solution. So I'm doing it just for the case of completeness. You don't need these two cases, case number 2, and you don't need this case number 3, because you all have square matrices only. Now, suppose rank of A is m, then there are two cases. That is unique solution provided m equal to n. And when m equal to n, you will get unique solution. And no solution, and sorry, infinite solution, infinite solution when m less than n. That is the thing. Next is rank of A is n. Then you will get again two things. You will get a unique solution, that is when m equal to n, and no solution if n is less than m. But the thing is that what you require is, you don't need to get all this. What you require is, you only require this portion. Wait, you only require this portion which I am marking. This is only required for you in your GGSIPU syllabus. In your GGSIPU syllabus of BCA math, only you need this case. You don't need to know all that cases. Now let's come to certain examples. Wait. Yes, let me come down to certain examples that will help you to understand the theory better. Let me take one, how to use this rank to understand whether the solution is finite, infinite, or sorry, unique, infinite, or no solution. That means I want to tell you how to understand whether the given system of equation has no solution, unique solution, or infinite solution. So basically this method of using, I'll be using the row operations. I will be using the, just a minute. Yes, I will be using the row operations. I will, and then you will, I'll be using row operations to find whether we have a unique solution, no solution, or infinite solution. And this method is called the Gaussian method. Gaussian method. Fine. Now let's take one by one example and let us now do it. And let us try to see what type of equations we get and what are the types of solutions we get, right? Okay, let us start with this. Let us take one by one solution, one by one question. Question number one and I'll be using that rank method also. See, the first question is for us is this. Let us take this matrix, this equation rather, x plus y plus z equal to 7, and then x plus 2y plus 3z equal to 16, and then we have x plus 3y plus 4z equal to 22. I have to write it in the form of ax equal to b. So this can be written as, you see, do one thing, you write as 1, 1, 1. I'm writing column wise 1, 2, 3, 1, 3, 4, and then you have your x, y, z, and you have your 7, 16, and 22. Now, see one thing, use the row operation. This is the one. R2 is R2 minus R1, and R3 is R3 minus R1. So here we will get 1, 1, 1, 1. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. And again from here, let me rub this. These two. From here we will do this and this row subtraction we will be doing. This and this row will be, wait. Yes, we will be doing this row and this row, this row, the first row. So 1 minus 1 is 0. Again, 3 minus 1. 3 minus 1 is 2. 4 minus 1 is 3. Similarly, I have to do this side also. I forgot to do this side. That is 7. 16 minus 7 is minus 9. Sorry, 16 minus 7 is plus 9. Extremely sorry. 22 minus 7 is now 15. This is 50. Let me rewrite it again. This is 9. 16 minus 7 is 9. And then now I have to make this 0. This I have to make 0. Now I will have the operation R3 is R3 minus 2R2. So now I'll take some more space and see what happens. Let me rub that. Let me uh, rub these. Wait. Let me rub this. Okay. Now you have 1, 1, 1, 0, 1, 2, and then see 0 minus 0 is 0, 2 minus 2 is 0, and then 2 minus 6 is 3 minus 6 is uh, sorry, 2 minus 2 is 0, 3 minus 4 is minus 1, and then this becomes x, y, and z. And similarly, I have to do here also 7, 9, and 15 minus 18, because this is 2 multiplied with 2, I'll get minus 3. So now you can see there is a pivot here, there is a pivot here, there is a pivot here. So how to write the augmented form? See, I had written, I will do two things in one go. See, what I'll do is that, let me rub this, otherwise you'll think these are minus sign. These are like this. See, I got this I got this matrix and I got this matrix. This is 3 cross 3 and this is a 3 cross 1. So this is the matrix A. Undoubtedly, this is the matrix A. This is the matrix B. So how to write matrix A, B in a combined manner? I'll show you. This is the augmented form. A combined B. This is the augmented form. Would be written as, see how to write it. How to write it? See, this you will write as 1, 1, 1, 1, 1, 2, 3, and you have your 1, 3, 4, 1, 3, 4. Now you put colons, you put here colons, and then you write here 7, 16, and 22. Now the operations that I've done here, you are seeing it. The operations that I've done here, that is, just a minute, it's going up. This operation, this operation, this operation, this operation, and this operation. These operations, sorry, it went. Okay. So these three operations will give me this same type of a result. You can see the same type of a result it will give. Either you do it this way or you do it this, you do it this way or you do it this way. If I use the same row operations, this whole thing, would reduce down to, will reduce down to like this. It will become like this: 1, 1, 1, 0, 1, 2, 0, 0, minus 1, colon, 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 and colon, colon, 7, 9, and minus 3. Now the thing is this, see one thing. There is a, see, what is the rank of, this is A and this is combined AB. This is just A. If you hide, this, sorry, just a minute. If you hide this column, still the rank of this A is, what is the rank of A? Rank of A, what you are getting? 3. Now what you do is that is the number of non-zero rows in A. That is the number of non-zero rows in A is 3. Now do one thing. Let me rub all this. Now let me rub this also. Now you see what is the rank of augmented AB. Again, this is again 3. Though now it is a 3 cross 4 matrix. Now it is a 3 cross 4 matrix, but the rank is 3, and which is equal to the number of variables. Number of variables are x, y, z, which is, so what you are saying is this rank of A is equal to rank of AB is equal to 3, which is equal to number of variables. So now let me rub this one. I hope you understood this one. Let me rub this one. Now this is equal to number of variables. Wait a minute. Let me write it clearly. Variables. So it has unique solution. It has unique solution. Unique solution. Now, how to find that unique solution? How to find that unique solution? Now you see this equation. Do one thing. You multiply this row with this column. You multiply this row with this column and multiply this row with this column and equate with this side. See, what I want to say is this. Let me rewrite this matrix. Let me rewrite this matrix below again. Let's see what happens. Let me rewrite. See, I'm rewriting it. What I'm getting is, see, what I got is 0, sorry, extremely sorry. This is 1, 1, 1, 1, and I got 0, 1, 2, and then I got 0, 2, 0, 1, 2, and 0, 0, minus 1, and I got x, y, z finally, and then I got is 7, 9, 3. Sorry, 793. 793. Now I have already shown why this is a unique solution. Now I have to find how to find the unique solution. How to find that unique solution. Unique solution. How to find that unique solution. Right? See, multiply this row with this row. So your x plus y plus z is equal to 7, and this is 0x. You don't not to write 0x. It is going to be y plus 2z equal to 9, and minus z equal to, this is was minus 3, sorry, this was minus 3. So from here it gives you z equal to 3. Put this z in this equation. Now put this z in this equation. You will get, wait, let me keep the equations. Yes, let me keep the equation a little more clear. Yes, now when you put y plus 2 into 3 is 9, that is y implies y plus y equal to 9 minus 6. So y equal to 3, you get y equal to 3. Now you got y equal to 3. This is one solution. You got this one solution. Now put these two values in equation 1. So now x plus 3 plus 3 is equal to 7. That means x is equal to 7 minus 6. This gives you x equal to 1. So these are the unique solutions that you got. x1, y3 and z3. Now let us see the second situation for no solution. For no solution, see, we'll see for the no solution. Let us take another example for checking no solution. Let me see. X minus 4y plus 7z is equal to 8, and 3x plus 8y minus 2z is equal to 6, and then you have 7x minus 8y plus 26z is equal to 31. Now see one thing. Now if I write it in the form of ax equal to b, I will get, c, I will get this. Let me write it here. I'll get 137, then minus 4, 8, minus 8. Then I'll get 7, minus 2, 26. And this is x, y, z. And this is 8, 6, 31. Now we'll use the row operations. R, make this, try to make this 0, try to make this 0. R2 is R2 minus 3R1, and R3 is R3 minus 7R1. Now this will give me 1, this will be as it is, X, Y, Z. This will be as it is. This 8 will be as it is. Now 3 minus 3 is 0. 8 minus 12 is this is minus 3. 8 plus 12, that will give me 20. Minus 2 minus minus 21 will give me minus 23, and 6 minus 24, because this is minus 3. 6 minus 24 will give me minus 18. Similarly, 7 minus 7 will be 0. Minus 8 plus 28 will give me 20. And similarly, 26 minus 49 will give me minus 23. And this is 31 minus 7, it's a 56. 31 minus 56 will give me 25. Now you see. Now this, I will have to make this 0. The next target is to make this 0. So I will use the row operation. R3 is R3 minus R2, and I will I will get, see, I will get 1 minus 4 7 0 20 minus 23 0 0 0, and I'll get here x y z, and I'll get 8 8 minus 18 and 25 minus plus, that will be 18. 25. Yes, I will be getting this as, yes, I'm subtracting. um, just a minute, let me check somewhere it went wrong. Wait. Okay. 31 minus, I got this as 31. So 31 minus 56. 31 minus 56. 31 minus 56 is minus 25. Sorry, this is minus 25. 31 minus 56. Now this is minus 25 plus 18. That is minus 7. So you will get this. So now you have, see one thing. Let us take some, let me keep this equation. Now this is your A and this is your B. Now if I write the augmented AB, if I write the augmented AB, I'll get 1 minus 4 7 0 20 minus 23 0 0 0. Now take some colons here. Take the colons. You will get 8 minus 18 and minus 7. Now this is your A and this whole is your A cross AB. Whole is your AB. Whole one. So what is the rank of A? Forget about this now. Forget about this. So rank of A comes out to be 2 because there are two non-zero rows. Now come to the complete one. Now this is a 3 cross 4 matrix, and this has three non-zero rows. See this one, and this one, because there is a 7 here. Rank of AB is 3. So rank of A not equal to rank of AB. So no solution, no solution, no solution. Even you can see this way also. Now suppose I multiply. I multiply I multiply this row with this column, and then wait, let me rewrite this. Wait a minute, I have to rewrite. Now you see, if I rewrite this whole stuff, see what I get. What I am having is 1 1 0 0. Then you have minus 4 20 0. Then you have got 7 minus 23 0. And then you have x y z. And then you have your 8 minus 18 and minus 7. If you multiply, you will get x minus 4y plus 7z equal to 8. Then you have 20y. Sorry, this is 20y. 20y minus 23z is equal to minus 18, but 0z is equal to minus 7. That means 0 equal to minus 7, which is absurd. Which is absurd. Absurd, and hence no solution, and hence no solution, no solution. Now you will see how to find an infinite solution. How to find an infinite solution. Now you see, what I do is that I take this type of an equation. Now I take an equation like this, that is x minus y plus 2z equal to 4, and then I have 3x, 3x minus 3x plus y minus 4 plus 4z equal to 6, and then x plus y plus z equal to 1. So then I'll have to write it as the form of x equal to b. Now see one thing. This becomes 1 3 1 minus 1 1 1 and 2 4 1, and you have your x y z, and then you have your 4 6 1. Then what you do is that you take the row operations. R2 is R2 minus 3 R1, and then you take R3 is R3 minus R1. By now you know why I'm doing this, because this is a 3 here, therefore the 3 has multiplied, this is a 1, so minus 1. So now let's write it down. 1 minus 1, 2. 3 minus 3 is 0. 1 plus 3, that will give you 4. And 4 minus 6 will give you minus 2. And then you will have this as 0 and this as, oh, we have to do this also here. I have to do this. Wait. So here it is 4. Now 6 minus 12 will give you minus 6. Will give you minus 6. And then 1 minus plus 1 is 2. We are 1 minus 1 and 1 minus 1 will give me 2 here. And then I'll get 1 minus 2 is minus 1. And then 1 minus 4 will give me minus 3. Here I'll get the same thing. Now I have to make this 0. So what I'll do is that I'll divide this row first with 2. I'll divide this row, the row, second row with 2. So what I'll do is that, wait, you see, R2 is half R2. So what would happen is, this will become 1 minus 1, 2, 0, 2 minus 1, 0, 2 minus 1, copied as it is. This is x, y, z. This is 4. Now this is minus 3 and minus 3. Now I have to make this 0. The operation would be R3 is R3 minus R2. So, so now we will have this. See, we will have this. Wait. Yes, here. So now we will have is 1 minus 1, 2, 0, 2 minus 1, 0, 0, 0. And I have your x, y, z. And this is your 4 minus 3. Minus 3 plus 3 will be 0 because of this operation. So now you see the augmented matrix. Let's see the augmented matrix. Let's see the augmented matrix. So this is 1 minus 1, 2, 0, 2 minus 1, 0, 0, 0, colon, and a colon. You put 4, you put minus 3, you put a 0. Now you see, this is A, the whole thing is B. Now, if you see, now the rank of this portion, just this portion, rank of, forget about this. Rank of this portion is, rank of A is 2. Now you see, now take the whole thing, remove this, now take the whole thing. So now the rank of the whole thing is, there are only 2 non-zero rows. So rank of A augmented B is again 2. So what I get is, let me drag a little bit down. Yes. So what I get is rank of A equal to rank of AB, which is equal to 2 less than 3, the number of variables. So infinite solution. Infinite solutions. And now you will see something. How to find this infinite solution? You need to come back to this equation. Wait, you need to come back to, sorry, this you need to come back. Wait, you need to come back to this equation. You need to come back to this equation. I have to copy this equation. So let's copy this. Now see, what you have got is 1 minus 1, 2, 0. Now what you have got is, what, just a minute. Yes, 0. Let me drag it up. Let me copy it. 0, 2 minus 1, 0, 2 minus 1, 0, 2 minus 1, 0, 0, 0. You have your x, y, z, and then you have, I think, 4 minus 3 and 0. Now we'll do one thing. Let me check, by the way. 4, 3, and 4 minus 3, 0. Right. Let's now come down to this. Yes. Now you write this, multiply this with this as I used to do. Let's rub this line. Okay, let's take it. X minus y plus 2z equal to 4. Then 2y minus z equal to minus 3. Now see, 0z is equal to 0. 0 equal to 0. So what you do is that take z equal to k. Z equal to k you take. Put this z value here. And when you find c, what I'll do is that now I'll keep these equations. Now you see 2y minus k is equal to minus 3. So 2y comes out to be k minus 3. Y comes out to be k minus 3 by 2. You got this? Y comes out to be k minus 3 by 2. Put this in this value and this value in this equation. Now you will get is see x minus y plus 2z equal to wait a minute, x minus y plus 2z is equal to 4. So now what is your value of y? Y is k minus 3 by 2 and your z is 2, z is k and this is 4. Take the LCM. You take the LCM. So x will be c minus k minus 3 plus k minus 3 plus 4k equal to 8. Take all of them on the other side. X is equal to x minus k plus 3 plus 4k equal to 8. So x comes out to be 8 minus 3 is 5 and this is 3k minus this becomes plus 3k here. When it goes that side it becomes minus 3k. So this is one such solution. Y you found out to be this and z is k. K can be any value, so they can take any number of values. They are not any fixed value because k can be any value from 0 to anything. So k can be 0, k is basically an integer. K can is basically belongs to integer. You can take any value, or let me say it can be any real number, any real number, any real. It is better to say a real number, or yes, a real number of your choice. Uh, A real number, wait a minute, a real number, k belongs to r, this means belongs to, this symbol means, this symbol implies, you have to write like this. See how to write this one. You have to write something like c here, and this is pronounced as ips, ip, epsilon in Greek, but here it will mean it belongs to. Here in set theory, this matter here it will belongs to. Here it will mean that. So k belongs to R. Now I'll tell you some very interesting facts about your rank and determinant. See, if the determinant of a matrix, determinant you can take of a square matrix only. Determinant is of a square matrix. Determinant A is 0 if and only if rank of A is less than n, and determinant of A is not 0, and I should also say A inverse does not exist. Does not exist. Does not exist. And if and only if a rank of A is exactly n for, remember both are n cross n. A is a square matrix because you can take determinant of square matrix only, and A inverse exist. Now see one thing. Now, sorry. Now see one thing. I will be showing you something very very important in the matter of rank. See, let me take one more example which will be very very interesting for you. Now, uh, let me take rank question. Let me take a matrix 1 2 0 minus 1 and 2 4 or 2 4 1 minus 2, and let me take 3 6 7 minus 3. Now this is, let us call this is the rank matrix A. What I do is that take the rank of A. Let me find the rank of A. So what I do is that I do this two operations. R2 is R2 minus 2R1 and R3 is R3 to be replaced with R3 minus 3R1. So what I get, let me pull it down a little bit. Just a minute. Just a minute. Yes. So I'll get this as A will be now like this. 1, 2, 0 minus 1, 2 minus 2, 2 minus 2 is 0, 4 minus 4 is 0, right? 1 minus 0 is 1, minus 2 plus 2 is 0, Now let's count for this. 3 minus 3 is 0. Now 6 minus 6, because this is to be multiplied with this row is to be multiplied by now with minus 3. So this is 0. 7 minus 0 is 7. And minus 3 plus 3. This is minus. Just a minute. Let me write it clearly. This is minus. So this is 0. Now do one thing. Sorry. Let me take a square bracket because I took on one side a square and I cannot take this way. Wait. Let me write it like this. Now I do is that I take R3 is R3 minus 7R2. So what I get is now what I get is, now I get this. Now this same A becomes now 1, 2, 0, minus 1, 0, 0, 1, 0, 0, 0, 0, 0. Now I have got two non-zero rows. I've got these two non-zero rows. So for the rank of A is 2. Therefore, the rank of this is 2. You can do this with the determinant method also, but that is very cumbersome. I'll tell you how it is. I'll just tell you how it is. I think this method is easier. Just take the rank and that ends the story. You do not decide the rank with determinant. It becomes very cumbersome. I'll tell you how it is. So rank of here it is 2. Let me copy down the matrix again and I'll show you what to do. This is the question. I'm doing it method 2. Method second. Let us call it method second. Now I have the same matrix 1, 2, 0, minus 1, 2, 4, 1, minus 2, and then I have got 3, 6, 7, minus 3. Suppose I take, this is a 3 cross 4 matrix, I can't take a determinant. So I consider another matrix A1, I make out of this, I take a minor out of this basically, the way by crossing the third column. Sorry, third column. I cross this third column. I don't take this column. What I do is that 1, 2, 0, 2, 4, 1, and 3, 6, 7. Then if I find the determinant of this, you know how to find the determinant. I'm just going to give you the answer. I'm getting 0. So now rank of, this is a 3 cross 3 matrix. So therefore rank of A1 is less than 3. Therefore, and A1 has been derived out of A1 A. So rank of A is equal to A1 less than. Now you consider another matrix here of this form. What you do is that you have to see, you have to do once this way by, see, I took these three columns. Now you can have to, you may do it in this way. You may take this column, or you may take this column and this column every time. You have to take, this is A1. Now you're taking A2. Let me write down, just a minute. Let me write down A2. Let me write down A2 for you. Let me write down A2. A2 I'm taking out of this only. That's why I'm writing in some different color. I'm taking out of this only. I'm getting 1, 1, 2, 3. And then I'm writing 0, 1, 7. And I'm taking minus 1, minus 2, and minus 3. If I take the determinant of this, I'll still get a 0. Therefore, this rank of A, which is this one, will be also equal to rank of A2, which is less than 3. Had this been 0, but this not been 0, suppose, let me write down, then only we'll understand. Supposing A1 was, determinant A1 was 0, but A2 determinant is not 0, then you could have supposed that rank of A is equal to rank of A2 is equal to 3. But this is not the case. This is not the case. I have told you in this in a different color, that's why. Supposing this matrix, this determinant was 0, but this determinant, this k in here 0, that's a different concept. It is 0 here, that's a different concept. I am saying supposing this A1 is 0, but this determinant is not 0. Then I can say that the rank of this upper matrix A is same as A2, but here it is 0. So I have to take another matrix, minor sort of thing. Let me write it with a different color. Wait. Let me write it with a different color. A wait a minute. I take A3 and this I take as 240017, and then I take as -1, -2, and set, let us say, 3. So I take the determinant of A3, I'm still getting 0. So perfectly, A rank of A is less than 3, but never 3. Is always less than 3. This is for sure after checking all these minors. Now let us take a 2 cross 2 matrix out of it. Let us take a 2 cross 2 matrix out of it. Let us take a 2 cross 2 matrix. Any 2 cross 2 matrix would do. Let me take this 2 cross 2. This 2 cross 2 matrix. Any matrix. If I take this now, if I take this one, let me tell you. Let me write this. Then you will understand what I'm trying to say to you. Suppose I take B1, let me call it B1, and I write 1, 2, I take this minor, 2, 4. Now, if I try to take the determinant, I'll get the determinant 4 minus 4 is 0. So, you will say the rank is not 2. But if I select B2 out of this 2 cross 2 matrix only, and I take 2, 0, 4, 1. In this case, if I take the determinant of B2, then I'll get is 2 minus 0, which is 2 non-zero. Therefore, the rank of A is same as rank of B2 is same as 2. So that means I have to take determinant for every step. For a 3 cross 3, see, I'm just showing you. Just a minute, I'm showing you this. See, for a 3 cross 3 method too, I had taken this determinant. I had taken this matrix, and then I found the determinant. This was 0. Now in this I took this matrix and I got this determinant 0. So the rank of is also not 3. Then again I took this matrix A3. Again this was 0. So rank of A is less than 3. I had to take 3 determinants. So that's why I'm saying, supposing in this situation, supposing this A2 was not 0, what I've written here, if A2 is not 0, then I could have concluded I did not go further for this thing. I did not go further for this thing. I can simply say that rank of A is 3. But since it came out to be 0, I had to find this. It came out to be 0, therefore I had to find this. Now again I had to find this. This came out to be 0. Then I had to find this, and this way I proceeded further till I got the rank. Till I got the determinant not equal to 0. So I think this method is bit more time consuming than this method. This is the method 1, which I use rank, straight away rank. So I'll call this method 1. I'll call this method 1, and a better method to find ranks instead of using the determinant method to find ranks. Oh, I think I have been able to make you understand a little bit of this. Now we will take one more problem, that is called the normal form. The normal form of a matrix is very, very important. Now, in the normal form, you are allowed to use both row and column operation. In normal form, you are allowed to use both row and column operations. Now see, I'll do one problem, then you will understand with this. Otherwise, we are only supposed to use only normal form. Let me write down normal form. Both row and column operations are allowed. Column operations are allowed. Only in normal form, no other form. Both row and column operations allowed. Only here I'm telling you. And otherwise you will only use this row operations. No column operations are allowed. Now you see, I'm taking an example. I'm taking one example and you will understand. See here, I'm taking this example. Let let A be equal to, this is your 1 4 3 2, this is your 1 2 3 3 4 2 6 7 5. Now you can see like this. This is a 3 cross 4 matrix. Use row operation straight away. R2 is R2 minus R1. You are replacing. And R3 is R3 minus 2 R1. So what you will get is, see, this you will get as 1 4 3 2 0, 1 minus 1, 2 minus 4 is minus 2, and then you will get 3 minus 3 is 0, 4 minus 2 is 2, and 2 minus 2 is 2 minus 2 is 0, 6 minus 8 is minus 2, and then 7 minus 6 is 1, and then 5 minus 10 is this is your wait a minute, 2 minus 2 is 0, 6 minus 8 minus 2, 7 minus 6, 1, 5 minus 4, that is again 1. Now do one thing, make this 0, make this 0. So what you do is that R3 is R3 minus R2. So now you will get this as 1432 0 minus 2 0 2 0 minus 2 minus 2 plus 2 0 1 minus 0 is 1 1 minus 2 is minus 1. Now do one thing, use the column operations to make this 0, make this 0, make this 0. You can do that. Now you can do this way. See, you use C3. C2 is C2 minus 4C1. Then you have C3 is C3 minus 3C1. Then you have C4 is C4 minus 2C4. 2C4. Now this has been done. Now this will bring this thing as 1, 0, 0, 4 minus 4. This side you are subtracting column by 0 minus 2, 0, 0, 0, 1. You are getting 0, 2, minus 1. Now what you do is that you add these two rows. You add these two rows. Now see, the target is to basically make an identity matrix. An identity matrix cannot be of 3 cross 4. It will be either 3 cross 3 or a 4 cross 4. So let's see what happens. What I am doing is this. I am multiplying C2 with minus half C2, and I am doing C4. I am doing this. So what I am getting is 1, 0, 0, 0. I am actually dividing this column by minus half. So I'll get 1 and 0. I'll get 0 and 1. I'll get 2 and 1 here. Now I'll do is that I will make this 0. I'll try to make this 0. Wow. I will subtract this column from this column. See. Now the thing is like this. See. You will do two operations. C4 is C4 minus 2C2. So, and the other operation will be C4. First, you do this operation. First, let's do this operation. See what happens. First, this is 1, 0, 0, 0, 1, 0, 0, 0, 1, and then 0, then 2 minus 2, 2 minus 2 minus 2. Here you will get 0, and then you will get 1 here. Now, the last operation is C4, C4 minus C3. In this, you will get 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. See, you're getting an identity matrix of order 3. So, this is therefore, the rank of A, which we took, was 3. Now, let me take one more example, and you will understand. See, here the rank came out to be 3. Now take another example. We will take one more example. Okay, here we'll take one more example. This is matrix, let us call it A only, no problem. 1 minus 1, 2 minus 3. Then we have 4, 1, 0, 2. Then we have 0, 0. Then 3, 1. And then we have 1, 0, 4, 2. Now you have this matrix. Now you see R2 is to be replaced with R2 minus 4 R1. Do this first because these are already zeros. These are already zeros. So now do this. So what I'll get is 1 minus 1, 2 minus 3, 4 minus 4 is 0, 1 plus 4 is 5, 0 minus 8 minus 8, 2 plus 12. This will become 2 plus 12. Yes, 2 plus 12 will become 14. No problem. 0, 0, 3, 1, 4. Then you have got 1, 0, 2. No problem. Now the idea is to make these zeros. Now See, this way you can make it zeros. Now you have got this. Now you do one thing. Uh, yes, you can do one thing. Yes, C2 can be written as C2 plus C1. C3 can be written as C3 minus 2C1. And C4 can be written as C4 plus 3C1. Now see what happens after this. After this, let me take some space. Yes, here it is. Here. Now you see, using this operations, I'll get 1, 0, 0. Let me write this. This will become 0, 0, 5, 3, 0. Then this will become 0, minus 8, 1, 0, and 0, 14, 4, 2. This is the thing. Now the idea is to do one thing. See, I may try to reduce these two expressions. What I'll do is that I'll try to reduce it. R2 is to be written as R2 minus R3. R3. So what will happen is now 1 0 0 0. See 0 3 1 4 and 0 0. And I can do one more thing. I can, so this is a 1 here, sorry. This is a 1 here by mistake. I wrote it 0. This is a 1 here. Now this is 0. Wait a minute. Now this is 4. What I can do is this. See, this mine plus R4. I do this thing. Now you see what happens. 1. I get 0. I get a 2 here. Now see. 3 plus 1, 4. Because I have to add and subtract from this. I'll get 0, 1. Now minus 8 plus all this will give me minus 7. 14 minus 4 is 10 and minus 2 is 8. Now you see things will become easier. Now after getting this, what I'll do is that I'll try to make this 0. This I have to make it 0. So what I'll do is that I'll write R3 is R3 minus 3 R2. So what I get 1, 0, 0 and 0, 0, 1, minus 7, 8. Now this is 0 minus 0, 3 minus 3 is 0, and 1 plus 20, 1 plus 21, that is 22, and 4 minus 4 minus 24, that is minus 20. And this is coming out to be 0, 1, 0, 2. Now what I do is that, now the thing is this, I will be doing C3 is to be added with C3 plus C4, and we will get 1 0 0 0 0 1 minus 7. Sorry, this is minus 7 plus 8 is 1, and this is going to be 8, and 0 0, 22 minus 20 will be 2, and this will be minus 20, and this will be 0 1 0 2. Now you can do one more thing. You divide this row 3 by 2. R3 is to be divided by half R3, and you will get 1 0 0 0 0 1 1 8 0 0 1 minus 10, and then you will get, let me write it too big. Wait, let me take some more space. Wait, let me take more space. Yes, let me rewrite it again. Rewrite it this again. This will be, wait a minute. Yes, this will be now 1 0 0 0 0 1 1 8 0 0 1 minus 10, and then you will have 0 1 0 2. Now the best thing is that you subtract this one. You subtract this column with this column, or you can do is yes, you can do is R3 R4 is R4 minus R2. So now you will get, let me take more space. Yes, wait. Yes, here. Now you will get is 1 0 0 0. Then you will have 0 1 1 8 0 0 1 minus 10, and then you will have 0 1 minus 1 is 0, and then 0 minus 1 is minus 1, and 2 minus 8 is minus 6. Now you got this. Now do one thing, make this 0, this one 0, see, and you make this 0. See, you do one thing. C3 is C3 minus C2, and C4 is to be replaced with C4 minus 8C2. Now you see what happens. Now you have 1 0 0 0 0. I'm using this one first, C3. So 0 minus 0, 1 minus 1. That is, you put write this one as it is, this is now 0, and now this is also 0, and because no, because of this you have this 0, this is 1, this is minus 10, this is minus 1 and minus 6. Now you see one thing, you make this 0, this one 0. How? What I did was that first I subtracted this row with this, and then I subtracted this row with this simultaneously here and here. That's why I got this. What I did is 0 minus 0, 1 minus 1, 1 minus 0 is 1, minus 1 minus 0 is minus 1. Then I did 8 minus 1 is 8 minus 8 is 8, minus 10 minus 0 is minus 10, minus 6 minus 0 is minus 6 here. That has been done. Now you will see. Wait, let me rub all these lines. Let me rub all these lines. Let me rub all these lines. Yes. Now let me rub this line and this line. Now see, the target is to make this 0. Now what I do is that very simple. I do one thing. I take little more space and then I'll do it. Wait. Here. Now you see. Wait. A little bit more. Yes. Now you see what I'll do is that I'll write R4 is R4 plus R3. Now you will get 1 0 0 0 0 1 0 0 0 0 1 minus 10 0 0 0, and then you are adding this to minus 16. Now the thing is very simple. Now do one thing. You do one thing. You divide this complete row, this complete weight. You divide this complete row, this complete, sorry, you divide this complete row, this last row by minus 16. R4 is minus 1 upon 16, R4. So what you now get is 1 0 0 0 0 1 0 0 0 0 1 minus 10 0 0 0 1. Now very simple. Just make this element 0 by either using the column or the row operation, that is your choice. Now you will see you can write R3 is R3 plus 10 R4. Now you see what happens is the last 0 0. This is the last line. This is the last step rather. 0 1 0 0. Then this is 0 0 0 1. Now this is, see, 0 minus 0. You are subtracting this 0. You are adding 0 plus 0 is, sorry, 0 plus 0 is 0. 0 plus 0 is 0. And 0 plus 1 is 1, and then you are adding multiplying this row by 10 and adding to this row. Therefore this is now 0. Now this is nothing but identity matrix of order 4 plus 4. Therefore the rank of A here is 4. This is the normal form. Okay,